with the Ohio LTAP Center, and we are pleased to have you with us this morning. Thank you for answering the poll question we have going right now. If you haven't had a chance yet to answer that, please do. We do want to get a good sense of who we have with us this morning. And I want to mention, I know that you guys are probably seasoned professionals now on this webinar software, but in the handout section of the GoToWebinar box, we have 3 items for you. One that says Work Zone Traffic Control Lesson 4. Please don't let that confuse you. That's Lesson 4 out of the training manual, but it is the material we will be covering today. We also have the Work Zone Design table as an image, and we've put in there for you the download of the pocket guide, the Work Zone Guidelines for Traffic Control in Work Zones. That is the current version of the pocket guide, and it of course relates back to the Ohio Manual on Uniform Traffic Control Devices. So that is in there as well for you to be able to utilize and keep as a reference for the future. If for some reason you can't get these items to download out of the handout section, don't worry, because we will also send them out as a link afterwards. So I'm going to go ahead and wrap up our poll real quickly and share the results, because I do show that 91% of you have voted. And while I'm doing that, if you wouldn't mind looking for a question section in the GoToWebinar box and just drop us a hi or hello so we know that you're here and that you found that. That's how we would ask that you put questions in that I can read off to our presenter today, is through that box. So poll question wise, 59% of you are from local government, followed by 31% from state, and then we have an even tie between the consulting firms and other at 5%. So thank you for sharing that with us. And I believe that's all I have right now. So Ray, you think you might need to reshare your screen.
Oh.
Yeah, because it looks like it's hanging up here just a little bit with this poll question. So I'm still seeing the poll question on my end.
Oh, did I pause it? Let me see here. Pause.
I think if you go up to the sharing and hit stop showing screen,
okay.
and then you can hit show again, and then
okay.
we should be able to see what you've got. There we go. We see your PowerPoint. So, all right, I'm turning things over to you now, Ray. Thanks.
All right, thank you, Victoria. And welcome everybody to part 3 of our 5-part webinar series on work zone traffic control and safety. Today we're up to lesson 4 in our manual that we have when we're usually when we're in the that other world where we used to have classroom sessions in the real world, not the virtual world. So today we're going to be looking at work zone traffic control layouts, and we're going to be talking about things like typical applications, and also the need we have to modify these typical applications. And we talked about that in our last session, where we looked at typical applications, and we talked about a lot of different reasons why why we need to alter these typical applications to fit the real world. You know, we took a look at the typical applications that are in the temporary traffic control manual, and then we looked at the real world locations, and we saw that the real world locations most of the time don't look like the pictures in the manual, so we have to adjust those. And so that'll be our focus today. And we're also going to be looking at different sources of work zone traffic control information. So we not only have the temporary traffic control manual, which is part 6 of the Ohio Manual of Uniform Traffic Control Devices, but we also have the ODOT website, which contains loads of work zone traffic control information. We have the some information on our Ohio LTAP webpage under our resources and programs, and also you can look up different training videos on our Facebook or our YouTube channel. And we have different links that you can click on our website, like direct links to the Ohio Manual of Uniform Traffic Control Devices. And we have our Route of Navigation series, which contains several pieces of work zone traffic control information, like a RON update. We call those RON updates. They're technical briefs and job aids for local governments. But route of navigation, RON comes from that, so we call them RON updates. So we have a RON update on helping you design your flagging operation, and another one on the considerations for mobile operations. But we also have on our ODOT website, a lot of different divisions within ODOT. In our engineering division, there is an Office of Roadway Engineering. And the Office of Roadway Engineering has tons of work zone traffic control information. So we're going to be taking a look at their website as well. So that's all part of today's session. So these typical applications, they're part of a traffic control plan, but they're really not scaled drawings. But we're going to take a look at traffic control plans that are scaled. And if you look at a standard construction drawing, every standard construction drawing or every standard construction plan has some pages devoted to maintenance of traffic, or MOT, and that's just another way of saying work zone traffic control. And so on that maintenance of traffic plan, you're going to see a scaled drawing of the roadway that's being worked on, and it's going to contain a list of the different traffic control devices that are required for that setup. It'll have some work zone or maintenance of traffic notes that are specific for that project and different requirements. And our major projects have a work schedule and the time that the different lanes are allowed to be closed. And that you might have copies of the different permits, especially like utility work's got to have certain permits to be worked on, and also have telephone numbers of like OOPS and the different phone numbers, contact numbers for the people that are basically in charge of the project. If you maybe if it's a city street, you're going to have the phone numbers for the city engineer and the different engineers and that are tied to that project. So here's an example, a page out of a maintenance of traffic plan. As you can see, it's a scale drawing. It's got these every 100 feet you have a station, like there's 140, station 147, 148, 149, and it's got different things highlighted, things that mean different things on here. Location of signs are called out. Here's your down in the right bottom right hand corner is some signs that must be in place for this work to take place, and these signs are taken directly from a typical application for a left lane closure. As you can see, the sign says left lane closed ahead. So we're going to get familiar with selecting these typical applications today and see how the different typical applications are tied to different roadway situations. Sometimes you don't have a maintenance of traffic plan from a set of drawings, especially when we're talking about our maintenance activities. And so, this webinar series is basically devoted to our roadway maintenance activities, not our big ODOT roadway projects. But this is devoted for local governments and how they handle their work zone setups for maintenance activities. And so sometimes your boss might hand you a hand drawing showing you how they expect you to set up your work zone that day. And so, and that's good because that's going to be utilizing a typical application as the basis of your work zone design that day. So it's very important that before you leave the garage to go out there and work on the road that day, that you have a plan in mind, maybe a hand drawing, or we like to stress a tailgate safety talk before the workers go out and work on the road that day. And part of that tailgate safety talk should be all about how you're going to set up your work zone that day. And so how you set up your work zone is based on a lot of different things. It could be the location of your work. Where are you working that day on the road? Not just the what street and where on the street, but also the location of your work within the right of way. So like, are you outside of the shoulder, not even on the road, or are you on the shoulder only? Are you on the shoulder and but maybe a foot or two out in the through lane? Or are you in a through lane of traffic or two lanes of traffic? And all that information is tied to a different typical application. And so the different lanes required for activity, the length of your work area, that's important, because maybe you're in a situation where um, even though you're not that close to an intersection, but when you set up your work zone and you calculate where all your signs should be, maybe that puts you back to an intersection or beyond an intersection. So that might make you go from using one typical application to a totally different typical application to fit that scenario. Also, time of day restrictions. That's talking about, are you going to be working during one of the rush hours, maybe the AM peak hours of traffic or the PM peak hours of traffic? If you're working on a residential street or low volume street, that might not have an impact on what you're doing that day. But if you're working on a major arterial or a freeway or something like that, and it's not an emergency, it's just routine roadway maintenance activity, then we really don't want you out there between 7 to 9 a.m. and 4 to 6 p.m. during the work week. And if you're looking at maintenance of traffic notes on projects, a lot of times that'll be called out in the maintenance of traffic notes as a restriction from working during those hours. No lane closures during those hours, because we need those lanes to be open during the peak hours. So the typical applications are listed in the OMUTCD, which we talked about in our first session. And we also talked about local standards. And sometimes your local government agency needs to develop their own standards for situations that that might not even be listed in the OMUTCD. We talked about some of those things, like roundabouts. You've got a 1 or a 2 lane roundabout, or up in Dublin, there's a 3 lane roundabout at 161 and Riverside Drive. And you're not going to find any information in the OMUTCD about how to close lanes in those areas. So like the city of Dublin, they've come up with their own standards for how to set up their work zones in the roundabouts. And then, as I've traveled around Ohio, I see a lot of different situations that are not in the OMUTCD. I was in Talmadge, Ohio, and of course Upper Arlington. What do those two cities have in common? Well, they both have an intersection that has 5 legs on it. So, if you're working at that intersection, you might have to come up with your own local standards of how you're going to set up your work zones that day, because there are no 5-legged intersections in the OMUTCD. So here's a list of the different typical applications. This page, it's not long enough to have all of them. There's 46 different typical application, but this is if you look at the index, then you can, it helps you to quickly find the typical application that you're looking for. So here's the rest of them. As I said, they go up to to 46. So TA-46 is the last one, and it's titled Work in the Vicinity of Highway Rail Grade Crossings. So if your work involves work near a railroad crossing, you might want to check that one out. But even though they're called typical applications, no work zone is typical. So as we discussed before, but we'll get into more detail here, there's usually a need to modify these typical applications to suit your specific location for that day. So you might need to add additional devices. An example of that would be maybe working around an intersection. You don't want people to make a right turn into the lane you're working on, so you might want to beef up the cones there so that you totally block that lane and people won't even think about driving in there. They'd have to run over the cones to get in there. Or upgrade devices, maybe add flags to your signs or lights to your signs, or increase distances. So we'll take a look at that. Sometimes with the sight distance issues, for instance, you might have to increase the length of your buffer space and merging tapers or things like that to suit that situation. Let's take a look here at, here's a picture of a work zone with too many signs, it says. That's a lot of signs, isn't it? They probably didn't need that many signs. So, the thing about typical applications is if you don't really have to guess about which signs to include. All the signs you need are listed there. It looks like they have a right lane closure in this situation. And so a standard right lane closure would only have 3 signs in the advanced warning area about undersigning. Maybe this situation has not enough signs. Let's see. Okay, so maybe this was just kind of humorous. So obviously, this is an emergency situation that would definitely call out for these lanes to be closed, right? So I wonder how many of you out there back
Ray,
in
I
the
certainly hope they put up more than just that sign if that had happened.
yes,
That picture's killing me right now. Oh my
I think
gosh.
that was put in here for some humor. Okay, so
Okay. I'm
but
glad you clarified.
in reality, I mean, I bet you there's some people in today's session that maybe your agency experienced some roadway washouts in the last year or two. We've had some very wet late winter, early spring situations. Even if with ODOT, we had we had several 2-lane rural roads get completely washed out. I know Highland County, I think in back-to-back years had some roads completely washed out. And what happened was usually on the 2-lane rural road, especially for culverts, maybe it's not a bridge, but a culvert. But in late winter and early spring, sometimes the combination of thawing and major rainfall is just too much for a culvert to handle, and it ends up just becoming completely washed out. So if anybody went through that, feel free to type something in the question box, and uh, you can tell us about it. Or upgraded signs. So we can add flags and lights to our signs. Another idea that we've learned about here at LTAP in the last few years is you can add a retro-reflective strip to the signpost if you're using post-mounted signs for your road work. But of course, a lot of times our maintenance activities usually don't involve post-mounted signs. Maybe you're most of the time using your portable signs, so that wouldn't be an option. Another thing you could do is double up your signs, like both sides of the road. that increases the visibility of your signs. Another situation, sometimes we increase the distances of certain aspects of our work zones, like we can increase the advanced warning areas or the increased taper lengths. So like if you were looking at typical application number 10, which is flagging on a 2-lane road, if you're dealing with a curve or some dips in the road, you can increase the your buffer space and the length of tapers to make sure that the flagger and the signs are not in a place where you would surprise the motorists as they drive around a curve. That would not be good. What was this say? Also, some other things that affect your work zone design is the work duration. How long are you going to be out there working? Is it just for 15 minutes or something, or is it going to be 3 days or more? That has an effect on your work zone design. The location of your road within the right of way, and also the roadway type. Is it a 2-lane road, a 3-lane road? There's a lot of 3-lane roads these days. It has a 2-way center turn lane in the middle, or maybe it's a 5 or 6-lane road, or maybe it's a freeway. All of these have an impact on the design of your work zone. So when I say duration of work, the manual speaks to 5 different types of work durations. You have your long-term stationary, intermediate-term stationary, short-term stationary, short duration, and mobile. Long-term stationary, that's like our big ODOT projects. It lasts for 2 years. Okay, that's long-term stationary. But the definition is it's work that occupies a location for more than 3 days. So in these situations, you must allow ample time to install your full range of temporary traffic control devices. And most likely you're going to be using post-mounted signs, not your portable signs. And inappropriate pavement markings should be removed and replaced with temporary pavement markings. We talked about that in our first session. And then when work is to extend into nighttime, then that's when we need to consider retroreflective and or illuminated devices to use. Then we have our intermediate term stationary, and that's work that occupies a location for more than one daylight period up to 3 days, or nighttime work lasting more than 1 hour. So if it's nighttime or up to 3 days, that's called intermediate term stationary work. And in these situations, it may not be feasible or practical to install the full range of temporary traffic control devices, such as altering your pavement markings or installing temporary barriers or constructing temporary roadways. And when work is to extend into the nighttime, retroreflective and or illuminated devices shall be used. Then short-term stationary is daytime work that occupies a location for more than 1 hour, but less than 12 hours. So most maintenance and utility operations are short-term stationary work. So that's an important scenario for this course. And short duration is work that occupies a location up to 1 hour. So devices having greater mobility may be necessary, and devices that are larger, imposing, or more visible can be used effectively. Mobility of the traffic control zone is important, and safety should not be compromised by using fewer devices due to frequently changing locations. Then we have our mobile work, and that is work that moves intermittently or continuously. So something like pavement marking striping, for instance, that's work that is moving continuously. Or sometimes pothole patching on one street or road where you have your crew walking behind the asphalt truck, filling potholes as they go along. That is mobile operations. So you need devices having greater mobility for this situation. And again, safety should not be compromised by using fewer devices due to frequently changing locations. And you also really need to consider your advance warning area. The thing about mobile operations is that you have more of a chance of surprising the motorists. So you really need to consider, um, put some thought in how are the motorists going to see us out here in this mobile operation. So sometimes you need to add signs beforehand. And of course, one of the standards of mobile work zones is your high intensity lighting. So you really need to have a good set of high intensity lights, flashing strobes. And we're not talking about your tailgate flashers. We're talking about real high intensity strobes, flashing lights. I know ODOT kind of recently updated our requirements for our high intensity lights. So we call it our 360 lighting package, so that the high intensity lights are visible from all directions, and it usually has high intensity strobes on all corners of the vehicle plus a light bar across the top that's high intensity. So some of the chores or tasks that are involved with mobile work zones, um, we're talking about situations with frequent short stops like litter cleanup, pothole patching, warning signs, rotating strobe lights on vehicles should be used and moved periodically with the mobile work area. And a shadow vehicle with an arrow panel or a sign should follow the work vehicle. And the key word there is should, because in some situations, should is okay, but also there's times when that word is shall. So you have to consider the need for the shadow vehicle in your different situations, whether it's a low volume road or sometimes even a low volume road needs a shadow vehicle. And that's when it's high speed, like our county and township roads, some of our state routes that are 2 lanes that are 55 miles per hour. And of course, the curves and dips in those roads are situations where the shadow vehicle is of the utmost importance. So the thing about mobile operations is most of the time, if it's a moving operation, you're moving, but you're moving at a speed of less than 3 miles per hour. So even though you're moving a whole lot slower than the traffic out there. So that's a problem. It makes you a target for problems, right? So that's why you got to make sure you're not going to surprise the motorists that are coming up from behind you. And so mobile signs or stationary signs that are periodically retrieved may be used. I know we're going to be talking about mowing on the rural roads, and some of the signs. You should have a sign that says mowing ahead, and if you're going to be more than a mile away or you've passed an intersection, then you need to consider moving those signs for those reasons. At speeds greater than 20 miles per hour, devices such as rotating lights, signs, or special lighting shall be on the work vehicle or on a separate vehicle with appropriate warning devices. So that would be, most likely we're talking about pavement marking, striping operations in that situation. So there are several different typical applications devoted to mobile operations, and they're all tied to where you are in the right of way. So if you're blocking a lane on a 2-lane roadway, then the typical application that you're going to use is typical application number 17. And so here's the picture of TA-17. As you can see, you got your work vehicle and a shadow vehicle, and then you have some other things that are called out as optional. And so you see a truck mounted attenuator that's optional on both vehicles, and a arrow panel set to caution mode. And the caution, we talked about two different types of caution modes for our arrow panels in the last session. One was a straight line or straight bar of lights, and then also the four corners mode. And as you can see in this picture, the four corners mode is called out. So specifically the four corners mode, not the straight line for caution. And that's because there was too many crashes or near misses with the straight line, and because the drivers would mistake that, they actually would think that the head of the arrow, the bulbs in the head of the arrow were burnt out, and so that confused the motorists, and they went around the shadow vehicle anyway, thinking that, and it was not meant for that purpose. So there was oncoming traffic, and so that would either cause a crash or a near miss. And so that's not good. So if you use the four corners mode, that eliminates that mistake. And you also see a sign on the back of the shadow vehicle. So you must have a sign on the back of the shadow vehicle in this situation. And as you can read here, I'm circling it with my arrow, it says use sign shape and legend appropriate to the type of work. That's very important because the motorists, when they come up behind the shadow vehicle, they usually cannot see around that vehicle. And so they need to know what's going on in front of that vehicle. And so an important piece of information that you need to give them is, if there's workers in front of that vehicle. And so we have a specific sign. If you're patching potholes, we have a symbol of the man with the shovel that we use for that sign. And so that it gives the two pieces of information to the motorist, one that we're patching potholes, but also that there's workers in front of that vehicle. And the studies have shown that if the motorists are told that there's workers in the roadway, then they behave better, a lot better. And so that's an important sign for pothole patching. But then you can also put a sign on there that's specific to that type of work. I know we've seen some new signs in the last few years, whether it be litter pickup ahead or um, tree trimming ahead, or things like that as well for that mobile operation. And of course, pavement striping. So there was a lot of information in this picture when you stop and think about it. But as for every typical application in the manual, there's at least 2 pages for each typical application. You have your drawing of the situation, and then you have the notes page that goes along with that drawing. And so the notes page is broken down to different paragraphs that contain standards. As you can see here, highlighted in yellow, we have the standards. And the standards are what we call the shall condition. So we also talked about that it's a state law to abide by the manual. So you are legally tied to using the standards at a bare minimum. And so in this case, as you can see, like if we read number 2, it says shadow and work vehicles shall display high intensity rotating, flashing, oscillating, or strobe light. So you could say that it's a state law that in a mobile operation on a 2-lane road, you shall have the high intensity rotating, flashing, oscillating, or strobe lights. You should never be out there in that situation without those. There's also some other standards, and then there's also the guidance portion. So you also see guidance and options. And so we use these to enhance the safety of this operation. So you're going above and beyond the standards when you use guidance and options. So when do you do that? Well, you utilize guidance and options when you're in situations where you have high speed and sight distance restrictions or higher volume and things like that. So if you're flagging on or using a mobile operation on a 2-lane 55-mile-per-hour road, then we don't want you out there with just the standards. We want you to enhance the standards by looking at things in the guidance and options. So what are we talking about here? Here's one. It says the shadow vehicles should also be equipped with 2 high-intensity flashing lights mounted on the rear adjacent to the sign. So that would bring more attention to the sign. What's another one here? It says whenever adequate stopping sight distance exists to the rear, the shadow vehicle should maintain the minimum distance from the work vehicle and proceed at the same speed. So that's saying that, well, it's what's the second sentence says the shadow vehicle should slow down in advance of vertical or horizontal curves that restrict sight distance. So that's very important. The shadow vehicle driver has to be trained to know that they should never disappear from view from the oncoming traffic as they uh, drive through curves and dips in the road. So it has to stop either at the top or right before the top of a hill or right before the beginning of a curve, and so the oncoming traffic um, can see their operation. You never want a 55-mile-per-hour vehicle to drive around a curve blindly and then they see the shadow vehicle, too late. We already talked about buffer spaces, and so we know how long it takes a vehicle to come to a stop from 55 miles per hour. That's a good question for the class. How about in the question box, somebody tell me what is the stopping sight distance for a vehicle at 55 miles per hour?
I'm ready to read that off as soon as I put it in there.
You have, here's your hint, you have that information in the
500 feet.
handout.
Is that correct?
All right.
We got 500 feet.
Well, let's see. I think they're
Somebody else said
really
500 feet too.
I think they're really close, but let's see. If we go to the guidelines for traffic control in work zones and we look at this, the bottom table on page 17, and we look at 55 miles per hour, and we go all the way across to the far right of that page.
Oh, we got somebody else said 550.
Well, let's see. Here I am. What's the somebody
Can you
type in
make
the
that a
right
little
answer.
bit bigger, Ray? I don't know about you, but I'm getting old and I need
Hey, that's
bigger
a good
things on the
idea.
screen. Thank you.
So at 55, I'm circling it here. If you go all the way across to flagger station / buffer. Remember, the buffer space is actually the stopping sight distance for that speed. So what's it say? It says 495 feet. So 500, I give you credit, but I just wanted you to have some practice using this table. And so if I wanted to be nitpicky, the answer is 495 feet. So that was some practice on using the table. So that'll come in handy for some upcoming quizzes. Okay, so guidance enhances the safety above the standard, but if we want to get even safer beyond guidance, we go to option. And so what are some options for mobile operations? We see a truck mounted attenuator may be used on the shadow vehicle or on the work vehicle. Okay, what is a truck mounted attenuator? Okay, it's a fancy name for crash cushion. And so at ODOT in the last few years, we have found out from experience that the truck mounted attenuator actually works very well in saving lives. And for instance, up in Marion County a couple years ago on Route 23 at a speed limit of 65 miles per hour, we had a right lane closure in a mobile operation, and an 18-wheeler driven by a distracted driver crashed into our attenuator. And the result was there was no fatalities. Okay, most likely would have been without the attenuator. And I think there was a minor injury. Someone went to the hospital but was released. But the attenuator did its job. It completely absorbed the impact of the crash, and without any serious injuries involved. And so, if you're in a mobile operation on a 2-lane, 55-mile-per-hour road, a truck-mounted attenuator is a very good idea. I like to tell people that if I was on a 55-mile-per-hour roadway working, I wouldn't even consider a mobile operation. I would always use a flagging operation. But, sometimes you can't do that for one reason or another. But the flagging operation provides more safety than the mobile operation does in those situations. Another good option is that says additional shadow vehicles to warn and reduce the speed of oncoming or opposing vehicular traffic may be used. And it says law enforcement vehicles may be used for this purpose. And so what's that telling us? Well, it tells us that motorists behave a whole lot better when they see the law enforcement vehicle flashing lights rather than our orange flashing lights. And so, anytime we can use law enforcement vehicles in our work zones, we do that. Not just mobile, but you'll also see us use law enforcement vehicles sometimes on our multi-lane highways and freeways. And so another one here, it says, if the work and shadow vehicles cannot pull over to allow vehicular traffic to pass frequently, a do not pass sign may be placed on the rear of the vehicle blocking the lane. So that's another sign to use on the back of the shadow vehicle when you do not want motorists to pass your operation. And I'm pretty sure there's some people in class today that know what I'm talking about there. If you're working in Ohio and you're on a 2-lane rural road, most of the time there's no place for the operation to pull off the road completely. And there's no big wide shoulders. A lot of our 2-lane rural roads have no shoulder or just a minimal shoulder. And so you have to consider that with the fact that you may not have good sight distance and you don't even know if a car is coming. And so it's good to just not allow traffic to pass. And so if you're in that situation and you're going to be there for a while, and you know that it's a rather busy road, and you know that when you do that, you're going to be backing traffic up a long ways, then maybe the mobile operation is not the typical application that you should use that day. You should use a flagging operation. That way you can keep traffic moving. So these are all things you have to consider before you select the mobile operation on your 2-lane road. Okay, you don't just automatically pick the mobile operation. A lot of thinking has to go into it before you select it versus flagging. And so here's some information on work duration. As you can see, you can find all the information on work duration in the temporary traffic control manual in section 6G.02. So what does it say about short duration work? Remember, short duration is up to 1 hour. So it's important that you're familiar with this top paragraph. It says, during short duration work, it often takes longer to set up and remove the temporary traffic control zone than to perform the work. Workers face hazards in setting up and taking down the temporary traffic control zone. Also, since the work time is short, delays affecting road users are significantly increased when additional devices are installed and removed. And so, in light of that, under option, it says considering these factors, simplified control procedures may be warranted for short duration work. A reduction in the number of devices may be offset by the use of more dominant devices such as high intensity rotating, flashing, oscillating, or strobe lights on work vehicles. So what this is saying is that you can, instead of having to install all of the signs that you see in the typical application, maybe you can get by with less signs. But when you get by with less signs in this short duration work, remember that's less than an hour, you have to beef up some other areas of the work zone, such as adding your high intensity rotating, flashing, oscillating, or strobe lights on your work vehicles. A lot of times, when we're talking about utility work, for instance, our utility workers usually have a really big truck that they use to get their work done, but it's also loaded with high intensity lights. And sometimes there's even a permanent arrow board on those vehicles, and it's there for a reason so that they can take advantage of this part of the manual. So if they're out there cleaning out storm sewer inlets, things like that don't take more than 20 minutes, then they can flip on all their lights, and that's why you usually don't see them with any signs. But I still tell them that in some situations, maybe they should add a sign or two, so that like on our major arterials that carry 18 wheelers, if they could give more advanced warning to the vehicles that can't see them because they can't see around the big trucks before they get there, maybe people could change lanes in advance, and make traffic flow smoother. And so, like I said, there's more than one typical application for mobile operation. It depends on where you are within the right of way or the type of road you're on. So we also have mobile operations for multi-lane roads. Maybe you've seen some of this situation on our freeways. And in this situation, we have a three lanes that are going in one direction, like on I-75 or I-71. And in those situations, we do have our big wide shoulders. And so as you can see, the first vehicle is on the shoulder of the roadway, and it has these arrow boards in the freeway situations are mandatory. And so, these high intensity lights are visible for a minimum of a half mile, even during the daytime. So very important to give the good advance warning to the motorists at their high speeds so they know what's going on ahead of time. So they have not one, but two shadow vehicles, each with their own arrow board, and then we have the work vehicle up here. And you see a sign on the back of the first shadow vehicle. And so, as it is with all the other typical application, there's a note page that's tied to this mobile operation for a multi-lane road, and it's got its own set of standards, guidance, and options. And so, at ODOT, when we are on one of our big interstates, we're going to have all of these included in our mobile work zone, not just the standards. And so the location of work, it's meaning where you're working inside the right of way. Here's a list. You got your outside the shoulder, or on the shoulder with no encroachments, or on the shoulder with minor encroachment into a through lane, or maybe you're working within the median or within the traveled way, meaning you're blocking a lane of traffic or more than one lane of traffic. All of these have a specific typical application tied to them. And so each roadway is characterized by differences in speed, volume of traffic, and operating characteristics. So let's take a look at different types of roadways. And so I think each person in class, you'll see that there's different roads. That some of these you have in your jurisdiction, maybe some of these you don't. But rural roads, let's take a look at those first. The characteristics that are tied to rural roads are usually they have relatively low volumes, but they have relatively high speeds. We learned in the first session or two that high speed means 45 miles per hour or higher. And so, a lot of township roads definitely fit this situation. Low volumes, but most of the time, legally, the speed limit, even if there's no signs, the legal speed limit on a township road is 55 miles per hour. So controls may be established by using typical layouts with minor alterations. So let's take a look at some of these typical applications that are tied to rural two-lane roads. So if you're mowing along a two-lane road and you're not in the lane of travel, you're not even on the shoulder, you're beyond the shoulder, that's typical application number one. And so as you can see, maybe all you need is a road work ahead sign if it's a stationary task you're doing, because you're not really affecting traffic in any way. You just want to let them know that you're there. And then here's one of the typical applications where you're working on on different parts. You're on a roadway in different locations working on the shoulders. So as you can see in this picture, there's 3 different work zones, and they're relatively close to some intersections. And so if you're doing this sort of work, then you see the an advanced warning sign. It says road work next miles, and then you have shoulder work in advance of your work area, and then you have a shoulder taper protecting your crew and equipment. And then on the approaching intersections, they have a shoulder work sign as they approach the intersection. And then sometimes you're on the shoulder, but you're out into the lane a foot or two. And so that's typical application number 6, which is titled shoulder work with minor encroachment. And so we can see in this picture that the cones, you got your shoulder taper, which is 1/3 the length of a merging taper, remember? And then your cones are out here in the lane of travel. And so in this case, you've got the sign says road work ahead or shoulder work ahead. Actually, you want road work ahead in this situation because you're encroaching. And then you also have the a buffer space, and then you have your work vehicle with a optional truck mounted attenuator protecting the work area. The hatched out area is the actual work area. And then you see a very important note here. It says, remember again, this typical application, then the manual was written by ODOT. So ODOT calls out a 10-foot minimum lane left over from your encroachment. And so that, that's in reference to ODOT having a 12-foot wide lane on most of their roads. And so ODOT's policy is we want to keep a 10-foot minimum lane open, which makes sense if you're ODOT because our roads carry a lot of commercial traffic, even our 2-lane roads. Now at the local level, you wish you had 10-foot lanes in some situations, like some of our township roads that have, a lot of them are 8-foot lanes to begin with no encroachment. So this drawing makes no sense. But here again, at the local level, you have to come up with your own policies. And then when I was at the city of Columbus, we had policies where we would allow ourselves to neck our lanes down to 9 feet on our major roads. But then some of our roads we would permit down to 8-foot lanes, and which was our streets and roadways that didn't really carry commercial traffic and things like that. So there again, when you work for a local government agency, you have to come up with your own policies. And then we have the flagging operation. And so it's typical application number 10. You need to memorize that number because it's probably going to be on a quiz, but typical application number 10 is very important. Plus, we're going to talk about flagging in detail in our next session. But as you can see, this
Hey,
typical
Ray,
application, yes.
got a question for you.
All right.
If someone would like to know why not always take the lane for short duration?
Okay, we're talking about this previous. Well, that's a good question, but it's all about the situation you're dealing with that day. Or maybe this is a really important 2-lane road and you don't want to take the lane. You want to strive to maintain traffic in both directions. So it's, that's this typical application exists so that you can still consider two-way operation. If maybe it's a more minor road, um, and it's a off peak or whatever, you can, or even if it's not off peak, some minor roads, then you can close the lane and set up you either consider a flagging operation or just put out the signs there's a typical application number 11 deals with low volume roads where you set it up in a way where you don't even need flaggers. The motorists can figure out themselves if they can go around you or have to wait on another vehicle. So in flagging, you don't have to guess what signs you're going to use. Usually when I travel around the state talking about flagging, I like to start off the class by asking people how they set up their flagging operation. And you've got people, kind of guessing on what signs to use. But our typical applications, especially in this one that takes all the guesswork out, you can see the signs that you're going to use right there. The standard signage package includes a road work ahead sign followed by a 1-lane road ahead and then the flagger symbol sign. And yes, we use the flagger symbol sign and not the sign that says flagger ahead. Okay, if you still have the sign that says flagger ahead, we want you to retire that sign and get the flagger symbol sign. And as you can see, they purposefully drew this typical application with a curve. And in the picture, you see that the flagger and all the signs are in the straight stretch of roadway before the curve. And then, because you never want to surprise a motorist as they drive around a curve at 55 miles an hour. And so this is, I refer to this as the standard signage package. And that's because when you read the notes page with flagging, you'll see that there's actually a 4th sign that we want you to use when you're dealing with high-speed traffic. And that's the sign that says, be prepared to stop. So there's actually 4 signs in a flagging operation when you're dealing with high speeds. Another situation, maybe it's for more of a long-term lane closure on a 2-lane road, is where we install temporary traffic control signals. That way we don't have to have a flagger out there 24 hours a day, 7 days a week. So this is becoming, maybe you've seen several of these lately, especially if we're dealing with like a bridge or a culvert replacement, well, mainly a bridge. Sometimes we close half of a bridge down, a lot of times on 2-lane roads, and we can keep those bridges open by maintaining 1 lane of traffic. And sometimes in our longer term 2-lane roadway projects, we have to close the whole road, but it's an important road, and the detours are just too long to make people drive that far out of their way. So we actually construct a temporary roadway around our work zone. So this is a road closure with diversion. That's typical application number 7. And then, of course, we always have the option to just close the road, right? So we're dealing with a 2-lane roadway closure. We use typical application number 8, and it shows you how to put up the detour signs for that road closure and the placement of our type 3 barricades. So that was our 2-lane rural roads and the different typical applications. They didn't show typical application 11, but it's in there, and that's for low volume roads. And then the next roadway that we are concerned about is our urban arterials. And so the characteristics of urban arterials are usually that they have high traffic volumes, but moderate speeds. So they could be anywhere from, there's a plethora of speed limits on these roads. Could be 25 all the way up to 45 usually. So we say that there's even 40-mile-per-hour roadways, and 35 is probably the most common. So with these characteristics, you may require additional traffic controls and revised spacing of devices to accommodate closely spaced intersections and closely spaced driveways, which are the access to businesses and public facilities. So here's a typical application. Most of these arterial roadway typical applications show 4-lane roadways. And of course, in the last 5 years, we've kind of waged war on 4-lane roadways, because we know that a high volume 4-lane arterial doesn't work very well in urban areas because there's always a car stopping in the interior lanes trying to turn left, and they block traffic, and they cause, a lot of crashes. And so, we've done a lot of road diets on these 4-lane roads, and always consider widening them for another lane, which is the center 2-lane left, 2-way left turn lane in the middle, which solves a lot of problems as well. However, there are still a lot of 4-lane roadways out there, and so we have a lot of different situations, different typical applications for these 4-lane roads. This one involves the closure of the interior lanes, and so whether you're closing both left lanes in this picture, you see the northbound left turn lane, the left lane, the left through lane, and the southbound left through lane are both closed. But maybe you're only closing one, so you can just use half of this typical application. But as you can see, you got your road work ahead, and then you have a symbol of the left lane merging over into the right lane. You can also add a sign that says left lane closed ahead in between these. And then it shows the merging taper. When we're on a multi-lane road and we're closing a lane, we use a merging taper. And it shows length L, and then the placement of the arrow panel, and in the buffer space, and in the workspace. And so let's see if we can remember how to calculate the length of a merging taper. So let me get out of this and
So
let's
Ray, there's
find,
a question that came in. It says,
okay.
we use the flagger truck in the lane work is being performed for added visibility. Why isn't a vehicle shown on typical application 10? Should we not be using one?
I don't know what they mean by flagger truck. You mean like a shadow truck?
You know what, I'll send you this
Okay,
question and then you can respond to it afterwards
all right.
and
Well,
contact that
remember,
person.
in a flagging operation, the buffer space is very important for high-speed roads. So the buffer space must be completely vacant, remember? So I'll get into the combination of flagging and mobile in our next session. A lot of times it's not a good idea. Just say that. Okay, so let's do this Minty question. We're going to see if you remember how to calculate your. Did I already do this? No, I didn't, did I? I did something
You
similar.
didn't, so you better explain to
Yeah,
everybody how to use it.
yeah. So to answer this question, you get on your phone and go to minty.com, or you can use your laptop, and you type in the code that you see at the top of the screen, which is 6559026, and enter that. And then it's going to ask you to select an answer for this question. I see somebody did it. All right, they're starting to roll in.
I love this one because the little dots all gather the most popular answers. It's just a nice visual instead of trying to figure out where things are on a chart or a bar graph.
How many people we have in class today? We got
We have
50?
50 people, so
Wow. Okay, people, let's get some more interaction here.
we only have a little over 10% who voted on this one so far. People
Come
are
on,
gonna have
Dave
to wake
Cryer.
back up.
Wake up, Dave Cryer. It's time for you to vote. My buddy Dave Cryer, he's retired from the city of Columbus. I saw his name on the list today.
There's one person that does have their hand raised. I just want to mention that we aren't taking questions through the raised hand feature, but if you have questions, you can put it in the question box and I'll read it off to Ray. So how long are you gonna wait for people to vote?
I'll let you decide.
Oh, no, it's your decision here, Ray. You're running the show.
Well, maybe if this is the first Minty question, so um, I would just give them some time to get to the website and kind of figure it out. Now, you stay logged into Minty when we're done, because there's going to be some, as long as you stay logged in, you don't have to type in any more codes. Right, Victoria?
Correct.
All right. I see that they're getting it. We can call this one.
Sounds
Everybody, I think someone just happened to click the wrong answer by mistake when they picked 100, but the answer is 540 feet. So I see everyone is doing really good at using the tables on page 17 of the handout. So it's the bottom table that you use to find the length of your merging taper. And as you can see on that table, it lists all the different types of tapers. And so, all right, shall we move on? Very good, class. Get back to my PowerPoint. And so this one we're dealing with a left lane closure or both interior lanes on a multi-lane street. So that's typical application number 30. So typical application number 30 is where all your multi-lane roadways begin. So 30 and higher is where you look for multi-lane roads and freeways. And then here we have a bunch of 2-lane roads in an area, and one of the roads has a closure, and so it's called overlapping routes with a detour. And so as you take a good look at this picture, you've got 2 routes involved here. You got Route 4 and Route 17 as an example, and how we notify at the intersections, all the intersections around there is where we put all the information about the road closures and the detour and the placement of the barricades, things like that. And so there's a note page tied to this too that helps you. It helps you with designing your detour. Then we have our urban streets and intersections. So in these areas, we have to have special consideration for peak period congestion, business and residential access, pedestrians, bicyclists, transit operations, and of course the intersections themselves. So typical applications 21 through 29 deal with your intersection work. And so each one of the typical applications from 21 to 29 show you a different type of intersection, whether it be multi-lane or a 2-lane, and also where you're working in a different area of the intersection. And I can assure you that you're probably never going to be working at an intersection where you're just using one typical application. You usually have to kind of glean information from one and another one, put it together to design your work zone that day. But here we have a situation kind of like maybe like Morse Road or something in Columbus, where we have 3 lanes in each direction. And they happen to be working at a center through lane at on the near side of an intersection. And so you can see the signage package for that. Road work ahead, center lane closed, and you got your other sign with the arrows out there so traffic knows to go on either side. With that sign's placed just inside the cone taper and right before the buffer space. It also has some an optional flag sign. This is also a good area. Remember, we talked about the different uses for an arrow panel. You can also, it's important to have an arrow panel that has the arrows pointing in both directions. And so you can, this is a good situation for that to be in place. And again, there's a note page tied to that as well. Each one of these has its own note pages with standards, guidance, and options. Then here we have a 4-lane roadway at an intersection, and the crew is working in the left lane on the far side of the intersection. And it gives you the signage package and the placement of cones, how they've created a taper and an entry. They've created a left turn lane here on the near side of the intersection, and the different signs to consider. But when you read the notes page for this, it also gives you another option to handle traffic, but it's all tied. You have to think about when you're working at an intersection, what's the volumes of the turning movements? And so if you've got a high percentage of traffic turning left at this a northbound left at this intersection, you can actually remove that taper and keep that lane open, but you have to have the signs that say left lane must turn left. And so that's something to, typical application number 22 shows how to do that, except it's for the right lane, but you see the idea in that one. Okay, here's a good question. We have to draw on the what we learned maybe in the prior session about barricades, but when we look at this picture, you can type an answer into the question box, but do you see anything wrong with this sign? Like I said, it's something that we really talked about, I think, in the last session when we talked about signs.
They're answering now. Slashes going wrong way. Arrow one way and barricade says the other.
Yeah, so yes, that's correct. So the
Tripped wrong direction. Sorry.
the lines on the barricade are telling motorists to go to the right, and the detour says left. So good one, class. Okay, what's this one say? Detour for a closed street. And so, number 9 was all about two state routes intervening and with a lane closure, and then this one is just a typical street with the detours. And so, of course, no two detours are alike. So between this picture and the notes page, they try to really guide you through the design of your detours and different
Hey,
things to
Ray.
consider. Yes.
There was a question about a typical application for setting up a work zone and a roundabout. And I told them
Oh,
about the recent
yeah.
find you made with, was it
Mhm.
Dublin who has that now? So maybe you
Yeah,
could share that with everybody afterwards.
the closest thing to a roundabout um, closure, you're not going to find. Here's one. This is this typical application number 26 is about the only thing we have that's close to a roundabout, because we force traffic to go to the right, as you can see in this one. But as far as a real roundabout, maybe even a 2-lane roundabout, you're not going to find that in the OMUTCD at this time. I'm pretty sure you're going to see it in the next edition of the temporary traffic control manual, but we have to wait for the national manual to be updated before we can update ours. And so the state of Indiana has several typical applications in their booklet, and also the city of Dublin has a worker's manual. So I know when you Google it, you'll see that Purdue University, which the Indiana LTAP Center works hand in hand with Purdue University. They did a lot of research on uh, lane closure designs for roundabouts, and also the Virginia DOT has a lot of good information about that as well. So if you're looking for roundabout maintenance of traffic plans, those are 3 good sources for that. Okay, so here's where the crew is working right in the middle of the intersection of two-lane roads. You would be utilizing this typical application. As you can see, sometimes that we talked about, sometimes you use regulatory signs mixed in with your warning signs. And you'll notice that too with back at typical application 23 and 22. You can see we have here regulatory signs that say left lane must turn left. And in TA22, it says right lane must turn right. And so there again, as we talked about in I think our first or second session, the use of regulatory signs to better communicate to the motorists of what's going on and where they need to go. Okay, so here's some other pictures. Right lane closed ahead. So here we have a multiple lane roadway near an intersection. You can see the use of the arrow panel to better communicate to the motorists. What we got here? Here we have a situation where this big multi-lane urban arterial street has a project where they've actually created an off-ramp to get to an intersection. Let's see. So, these are atypical. You're not going to find typical applications for these situations. How about this one here? Can you identify the problem locations? So this crew is working, it's on a one-way street, but they're at an intersection. And they've got a sign here that they made themselves. Sidewalk closed ahead. So you don't have to write anything. I'll just, that's not the proper way to do that. We actually have typical applications that are that deal with sidewalk detours. So you would use that. Here's I think this is on West Broad Street in Columbus. So we took this picture because we didn't really like how the crew did it. This is a very common operation, but what they've done here is that if their work truck gets rear-ended, then they're in trouble, right? So they should have created a better buffer space in that situation. And then they could have used the way their arrow panel is, their arrow panel only has one arrowhead. Maybe they probably have the option to put both arrowheads on, which would have been better. It looks like traffic isn't paying attention anyway. So there's all the traffic's on the right. So they could have used the double-headed arrow. So the next set of those are the urban arterials and different typical applications and considerations for those. And then we step it up and we talk about our major arterials, freeways, and expressways. So these are roadways that have high speeds and high volumes. So these roadways demand the highest type of control and modification of typical applications to supplement the recommended array of devices. So again, even these 4-lane roads, you can also think of them as high-speed roadways as well. This is not the way to do it. These lanes were closed, and they just sort of made a dead end and put these arrow signs here. This is a situation where they should have had a long, either one merging taper or back-to-back merging tapers. Here we have a lane closure on a street with uneven directional volumes. So this is looks like a longer term project, but they would have one lane closed for morning rush hour and then flip-flop it to have a lane closure in the other direction in the evening to handle the uneven directional volumes with the morning rush and PM peak hour. Here's a good one here. We have how to close half of a 4-lane road. And so it's a combination of, this is typical application 32, but they start you off with the typical right lane closure with a merging taper and arrow board. And then you go a certain tangent distance, which is, in this case, half L, half the length of your merging taper. And then they have a shifting taper. So that's a difference of utilizing two types of tapers on one typical application. So you got your merging taper to close the right lane, and then a shifting taper to move traffic over into what used to be the southbound left lane, the interior lane, and then shift them back with this arrow. So you see the shifting to the left arrow and shifting to the right arrow for the before and after the actual workspace. And in the southbound traffic, that's the southbound right lane. So that's a typical right lane closure for southbound traffic. So the right lane closed, or I mean, yeah, right lane closed ahead, and etc. to get them over into the right southbound right lane. As you'll notice, there's a buffer space for each direction. So the freeways they have design considerations that include high speed, high volume, and there's no driveways or intersections. They have interchanges, and so we could start off by maybe we're only working on the shoulder that day of a freeway, or freeway lookalikes. Like Route 23 in certain areas, it's a freeway lookalike, but it's got the wide shoulders. And so, of course, if it's a long-term operation, we would consider, the barrier wall and things like that. But, for your maintenance operations, you wouldn't be installing that, but you would have these signs. And again, we have our signs on both sides of the road that say road work ahead, right shoulder closed ahead, right shoulder closed. And of course, we have if we're not using this wall here, we would have our arrow panel on caution mode because we're not closing a lane. And of course, at ODOT, we always have our attenuators. And then here we have a standard right lane closure on a freeway or 4-lane divided highway, and it shows the signage package where the signs, again, all the signs are on both sides of the road. So there's 6 signs in this advanced warning area, and then a shoulder taper protecting the arrow panel, and then emerging taper and buffer space, etc. So that's typical application 33. 37 is where we have a freeway with 4 lanes, maybe even 3 lanes in each direction. And you'll see that we don't have one really long merging taper to close 2 lanes. We have back-to-back merging tapers with a tangent space of 2L in between. And the truck-mounted attenuator before the workspace. And then finally, we have our work in the vicinity of an exit ramp. So as you can see in the picture on the right, we've created a theoretical gore area with our drums. So we really define that exit for our motorists out there, along with the signs that you see included with this typical application. And again, there's a note page that spells out a lot of different things that you run into out there and how to use different standards, guidance, and options. So let's come up with another question here as we're running out of time. We have, if I go to Google Maps real quick, let's talk about how we can use Google Maps to help us out. I like to use the satellite version, and then if I zoomed in here, in case you didn't know, I'm coming to you live from Circleville, Ohio today, but down here at near Circleville, of course, if we've got different roads. But what if I was on Route 23 in this area? It's a 4-lane divided roadway. For some reason, it's called out as Walnut Street here, but that's Route 23. So if I was going to close the northbound right lane, which typical application would I use as the basis of my design out here? So if I go to Mentimeter, hit escape, how do I advance here? Okay, so you guys tell me if you're looking at your
Are you just going to click on,
handout.
there you go.
I think this is the word. I think they can just start typing.
Yeah,
Which
they can.
which typical application would I use for a 4-lane divided road with a right lane closure?
And their responses will just show up on the screen.
If anybody's having trouble, I think there we go. It gets bigger as the more people, if people select different things.
Well, we're a minute over, so I think they're all waiting
All
to
right,
see if you say that's a good one or not.
there you go.
One person must be having issues with
Okay.
submitting on Menti, and they
Yeah.
put in the question box
Yeah.
typical application 30.
Yeah. There you go.
But it looks like the majority are saying 33.
And that's correct, right? Am I right?
Are you right, Ray?
You
You're the
know,
one
how
that's
do I check? Well, I'll show you how we select. You zoom out of this a little bit and move this box out of the way so I can move.
I think you got to hit escape on Menti.
Here we go. There's 30.
I'm not seeing it, Ray.
There it is. 33. Yes, 33 is correct. Right there it is on page 39 of your handout.
All right.
Okay,
Well,
so that was a good quick exercise on how to select the typical application as the basis of your design before you have to do any um, alterations, modifications.
well, thank you, Ray, for the
So,
interactivity
so
today.
to summarize, we learned a lot of, we also learned a lot of different sources for work zone information. You've got your, not only this little booklet here, but also the temporary traffic control manual, which is part 6 of the OMUTCD. We learned the ODOT website, which has the LTAP web page with some good work zone information listed under our resources and programs, and then also the Office of Roadway Engineering, which has tons of work zone information. Like this page here, maintenance of traffic. When you're on Roadway Engineering's page, you got all these things to click on the left side of their page. Is that coming up on the screen? And then
Yes, it is.
just tons of work zone information as you scroll down. But down here you have standard construction drawings. And when you click on that, my computer's thinking, we have an entire list of maintaining traffic standard construction drawings. And so closing the right lanes of a multi-lane undivided or divided, closure of a two-way left turn lane. You won't find that in the manual, but if you click on that, you'll see how to close the center two-way left turn lane right here. So that was another example of how I was able to use the ODOT website and roadway engineering to find information that was not in the temporary traffic control manual. So it's important that anybody that works on the roadway, they are familiar with all of these different sources of information, how to find them quickly.
And Ray, maybe you can just recap that real quick at the beginning of the next webinar,
Yeah, I will.
since we need
That'll
to let
be
folks go.
a Menti quiz question as we kick off next week's session.
That's right. Well, everybody have a great weekend. Thank you for being on the webinar today. And thank you, Ray, for the great information.
You're welcome.
So we will see everyone next session. Thank you.
See you next week.